Okay, welcome everyone. It might be a bit premature, but welcome to Applied Math, remote Applied Math, I suppose. For everyone who was in school on Friday, and there was only a couple people, but we actually, I assigned the law of single measures, so that's what we were working on. I had done the examples like solving for a side. Prior to that, I had assigned the law of sine solving for a side length, and then on Friday we did solving for an angle. I'm not really sure how you want the class to work, but I do want to let you know that live chat is on during live streaming. So if you have a YouTube account, and it tells you a little bit more on the blog how to set up a YouTube account if you don't have one, but you can just pop into the chat room anytime during class and ask me questions or correct me if I make an error. Hopefully that won't happen too often. But what I thought I would do is I would quickly maybe go through the assignment. So if you've already done the assignment and you don't have to, or I thought maybe I'll pick a couple questions from the assignment and then we'll talk about law of cosines. So solving, using the law of sines to find an unknown side length or angle measure. As I mentioned in class, the beauty of the law of sines, very similar to the law of the sine and cosine and tangent ratios that we used. They can be used to find a side or an angle. Same with the law of sines. We can use the law of sines to find a side length or an angle because the ratio itself, if you look at the ratio, once again, the law of sines, if I have little side A partners with angle A, little side B partners with angle B, we only ever need 2 out of the 3 ratios, and we use the cross multiply technique. And as I mentioned in class, when we label a triangle, the only reason we're doing this for law of sines, we're labeling a different way. We don't have a right angle triangle anymore, so we don't have hypotenuse, adjacent, or opposite anymore. So the only way we label a triangle is we call the angle measures themselves capital letters of the English alphabet. So if this is side A and this is side B and this is side C, the only reason we're doing that is to establish the partnership within triangles. So if this is capital A, the side directly across from it would be little a. If this is angle B here, this angle B, this would be little b. And if this is angle C here, this would be little c. Now we're just establishing how the partnerships work. As I mentioned in class on Friday, I don't label my triangles in a word problem A, B, and C. I just use that A, B, and C to establish the partnerships in the beginning. So I know that if this is my angle, then this would be its partner side, right? These guys are partners. And if this is my angle given here, the X would be his partner. So I'll just quickly do one of these just to kind of establish that we've where we are. So if I'm told to find X, I first establish there's a partnership. So sure enough, 12 partners with sine of 39 degrees. Remember, a degree measure is meaningless unless you have the word sine, cos, or tan in front of it. And X would partner with the angle 53, so it sits on top of sine 53. As we mentioned again last week in class, that the cross multiply method is used if you know 3 out of the 4 pieces of a cross multiply ratio, like one fraction equal to another. If I'm told to solve for X, so X is my unknown, that's what I'm solving for, I multiply the 2 numbers that meet on the cross and divide the leftover number. So 12 times sine of 53 divided by sine of 39 degrees. Now, if you're using a graphing calculator or the graphing calculator simulator, you'll recognize that the graphing calculator 12 times, and it was sine 53, sine, and it opens the bracket, 53 close bracket, divided by sine 39. I'm in degree mode as well. And I get the answer 15.23. Okay. Just going to see if I can if that makes a difference at all. I don't know if it does. Okay. So x equals 15.23 meters. All right, let's try one with an angle measure. So if I take a look at number 4, I established there's a partnership. So this is the complete partnership, right? So 23 sits on top of sine of 40 degrees. And that means 35 partners with my unknown angle, sine of theta. This time I'm solving for an angle measure. So I process it the same way. Hi, Tanis. Yep, I'll go over number 5. So this one, I know these two guys for sure. So I'm going to multiply, divide, and that's going to give me my unknown. As we established on Friday, I think, times sine 40 divided by 23. You'll notice that this only helps me solve for sine of theta. So in order to solve for theta, the very first thing I have to do in my calculator is access that shift sign. And then I'm going to do my 35 times sine 40 divided by 23. So in the calculator, it looks like this. And I don't know if you guys can see this because it's not very bright, but so in my calculator, right above sine, there's the shift sign button. So I shift sign 35 times sine 40, and I'm going to close my bracket, divided by 23, and I'll close another bracket because the calculator opened, and I get theta equals 78.00 degrees. Okay. And Tana said that she's going wanted me to go over number 5. So what I'm going to do, let me just respond to I'll do that one in a minute, and then I will post the PDFs of the booklets on my blog. So then you can at least have them. Okay, let's take a look. This is what I have on my Tanis. I don't know what book. Can you tell me? I'm using a book that says June 2019. So I hope you are as well. That's very strange. Thanks for letting me know. This is what I have in my booklet. So if you guys are missing a number, I sure hope that there's not a lot missing in your books. So I see that I have a perfect partnership here. And I'm looking for X, right? So if there's something missing in your book, okay, Tanis, oops, that's all I can say. So I guess record that in. I guess without the 173, Tanis, you couldn't do the question. Okay, so there was a misprint in your book. I hope that the rest of people don't have a whole bunch missing. So this, you can see that with the 173, it's pretty straightforward, right? Sine of 58 equals X over sine 22. So then again, I'm solving for X. I find them a little easier than solving for angles because I don't have to use that shift sign key. So X equals 173 times sine 22. And I'm really conscious of that closing the bracket divided by sine 58. And let's hope we get and we get 76.42 inches. Yeah, without that 173, there's no way you could solve the question. So that's impossible. And then everything else seems to be pretty straightforward, I think. So you can let me know too. I can always go back and do old questions. Later on too. Like if you have a question in a couple of days about a previous assignment, feel free to ask me. I thought I would go on to law of cosines. And again, I'm not quite sure. Like I say, I can post assignments on the blog. Maybe I'll end up setting up a Google Classroom if I can get all my assignments on Google Classroom. Stay tuned for that. It kind of depends how long we're going to be out. If we're out until June, then I'm definitely going to try and figure out a better way to access or have you access materials. So keep following along. That's awesome. All right, let's talk about law of cosines. Now, again, if you missed, and there were only a couple people in class, so you missed sort of the lesson. If I look to the front of my book, and maybe Tanis, if you can look, if you could just type in what your book says. I'm using a June of 2019. I'm not sure what yours says, so hopefully we're using the same books. But if you look at the title page, the triangle stuff is divided into two sections, right triangles and oblique triangles. Right triangles are those with 90-degree angles, right? Those with 90-degree angles. And these oblique are those without 90-degree angles. So these are the type we're doing in the last couple of days. And this is the type of, there's so many triangles involved that don't have, I don't know what there shouldn't be too many differences. So hopefully, Tanis just typed in that she has a different booklet. Tanis's book says February and mine says June. So there might be slight differences. I don't think it's going to be that much of a problem. Contacting each other throughout our time. So if I look at law of cosines now, because law of cosines, again, law of sines and law of cosines are those, we use these triangles or these laws to solve missing parts for triangles without a right triangle. So again, law of cosines, then the labeling is the same. Angle A partners with little a, angle B partners with little b, angle C partners with little c. And I mentioned on Friday that we can only use law of sines when we have a complete partnership, right? And as you just saw a second ago, sorry to keep flipping back and forth, but as you saw when we were just doing this couple of questions here, I always started out every law of sines. I had a complete partnership. I had a side and an angle, a side and an angle, a side and an angle. There are going to be some questions where we don't have a complete partnership. So you can see I have this angle. If I look on page 21, I have this angle and I do not have the accompanying side. I have this side, I don't have its partner angle, and I have this side and I don't have its partner angle. So that's when we use the law of cosines. So I'm going to flip back again. To solve using law of cosines, there are two versions. The first version is solving for a missing side, right? And in our triangles, we're solving for x, right? So when we're solving for x, the missing side, we use this formula. And the A, B's, and C's hopefully make sense. This is where we will use our A, B, and C in capital A, B, and C. This is solving for an angle, right? This is solving for theta. Okay, so This will make a bit more sense when I do these in a minute. So we use the law of cosines once again when we don't have a complete partnership. So if I look here, even if I wanted to try following or using the law of sines, I couldn't set up a complete partnership. So therefore we use the law of cosines. And for law of cosines, I will label what I'm given. So I look at the angle I'm given, okay? And I'm gonna call this angle A. So this could be known as like side A, even though they're calling it X. And these are my two sides given, like this would be B and C. And it doesn't matter which one goes where. You could call this angle B, this angle C. The only thing that really matters is whatever side you're looking for with the law of cosines question. If you're looking for side X, that means you do know the angle given. There's one angle given, and the partner of the angle given is the side you're supposed to find. So if you look again, I'm just going to record the law of cosines up here again. The law of cosines says a squared equals, when you're solving for x, b squared plus c squared minus 2 times b times c times cos of a. So all they're getting you to do is take the two sides given, square them. As long as I have this established, it's very easy. I'm just going to call this x because that's what I'm being told to use in the question. So x squared will equal 5 squared plus 7 squared minus 2 times 5 times 7 times cos of the angle given. So once again, you can see you're just taking the two sides you're given, you're plugging them in here, 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 and here. And then it ends with the angle given. So you're given 3 pieces of info, right? 1, 2, 3. These are your two sides. This is the angle. I'm going to go back in a second, talk about the law of cosines in general for a moment, but this is it. So x squared equals, what you do is type this big mess into your calculator. There's no division involved in the law of cosines, solve for a side. So we just type this all into your calculator. 5, now there is a squared button here that you can use, squared plus 7 squared minus 2 times 5 times 7 times cos 51. It's going to give me x squared is 29.9475 ... Okay. But you'll notice that that is actually solving for x squared. So I have to square root this. So I'm going to show you now, there's a couple ways you can do it. You can use the square root button on your calculator if you want, right? So just hit the square root button and then type in at least 6 decimal digits after the dot. So 29.94757.263. I would just type in everything I see, and you're going to get an answer of x equals 5.47. Now, you could actually type this, the other way you could do it, I'm going to show you another way in a minute. You could have typed your square root. You could do this as well. If x squared equals this, x will equal the square root of 5 squared plus 7 squared minus 2 times 5 times 7 times cos 51. Right? You could just do everything in one step, so you don't have to do that extra step. So it would just look like this. So just press your square root button first, and then just type this big mess in. 5 squared plus 7 squared minus 2 times 5 times 7 times cos 51, right? And you'll get the same answer, okay? That might be easier in a way. All right, so when we're solving for a side, okay, the law of cosines is maybe a little trickier than the law of sines because it kind of looks like it has 2 different versions. These are actually just the same version. This has just been manipulated to solve for an angle. This is for a side. But I just want to go back for a sec. You're only going to use you're going to be given, when you're solving for log cosines, you're given this info. You're given the side, an angle, and another side. And you're told to solve for x. So you can easily recognize log cosine questions. You're given side, angle, side, like you're given the info. It's like a sandwich, right? So you're given the side, the angle, and the side. So almost like the sides are eating the angle. You're given all the info clustered here, and you're trying to just find for that third side. Now, the other time you have to use law of cosines, which we're going to see shortly, is you're just given the angle. You're given a side, and a side. And you can see this won't be a law of sines question because you're given no angles. So you're either given side, angle, side. Those are the law of cosine questions, or you're given side, side, side. So if you're given either of these cases, it's law of cosines. Otherwise, it's all law of sines. Okay, let's try this one again. So it says find the length of side x. You can see I'm given side, angle, side info, right? Side, angle, side. So it's law of cosines. So I know that x squared will be equal to, right, because this is the side, it's going to be equal to 23 squared plus 15 squared minus 2 times 23 times 15 times, it's my 15 times cos of 29. Okay, so that's the law of cosines. Remember, a squared equals b squared plus c squared minus 2bc cos of a. Okay, so again, it doesn't matter who I call b and c. That's why I didn't even label them. It's just one side squared plus the other side squared minus 2 times both sides times cos of the angle. All right, let's do this all in one calculator move though. X will be equal to the square root of this. 23 squared, 15 squared, minus 2 times 23 times 15 times cos 29. And everything gets punched into your calculator. I'm going to clear this out. Okay, square root button, 23 squared plus 15 squared minus 2 times 23 times 15 times cos 29. And that's going to be equal to 12.27 feet. I guess this was meters. Okay, so that's the law of cosines for solving for a side. Now, the reason I'm kind of telling you, I gave you these two instances, like this is when you use law of cosines, because we're going to see shortly, you're just going to be given a big assignment or on a test, and we'll have to talk about tests in the next day or so. You're just going to be given a question sheet with a whole bunch of law signs and cosines mixed up. So you have to ultimately decide, is it a law of cosines or law of sines question? That's why I'm telling you when to recognize law of sines and law of cosines. Okay. Should we move on? Okay, you tell me. Are you ready or should I give you some time? Okay, thanks, Tanis. At least someone's responding. All right, I will go on. I mean, you can always stop and start this video anytime you want, like if you review it. So I'll go over the next set of examples so you can do the next assignment. So, of course, you know what's coming up. We just used the law of cosines to solve for missing side, and now we're going to use to solve for missing angle, all right? Now, just so you know, there really aren't two, and I could show this to you. Maybe what I'll do is at the end of this video, I'll just explain to you why there are two different versions, but this really, they are the same formula. It's just been isolated in a different way. So when we're solving for an angle, we obviously know we're solving for an angle because there's a theta and it's a solve for theta. And you'll notice this is a law of cosines question because I'm given the info you're given is side, side, side. You're not given any angle measures. Therefore, it's definitely not a law of sines question. We can't set up a law of sines because there's no angle measure. We don't have a complete partnership. So therefore, whatever angle you're given, now this is the law of cosine solving for an angle. It's cos of angle A equals B squared plus C squared minus A squared, all divided by 2 times B times C. Okay. So what I have to do is I have to solve for angle A, and angle A is going to be my theta, right? This is angle A, also known as theta. Now it does make a difference in these questions. You have to be able to identify who A's partner is. That's really important. So this is little a. Whatever angle you're solving, this would be the side associated with it, right? Now it makes a difference who you identify A as, because you'll notice in the formula, B and C are added, only A is subtracted, right? Only A occurs here. So it doesn't matter, once again, who you call B and C, they're just being added together, but it matters that you can identify where A is. Also, remember how in law of sines we had to do that shift sign at the end? The same thing we're going to do here. I really don't want cos of A. I just want angle A. So angle A is I'm going to have to get rid of cos. So I'm going to do that at the beginning, just like I did before. And now you're going to have this big, long question. So pay attention, sorry to me. This is going to be tough. So I'm going to use brackets within brackets because I want to bracket this off too. So it doesn't matter who you call B and C. So it really doesn't matter who you call B, C, but I'll just label them here. So I've got 9 squared plus 6 squared minus 7 squared. And I'm closing the brackets. This is a very, very technical question. And now I'm going to divide out 2 times B times C. Okay. And I'm going to bracket these guys too, right? That makes sense. So in all, you're going to have 1, 2, 3 sets of brackets. So it's the hard part about this question is just punching it into your calculator, okay? So let's see what that looks like. And the reason I had to put these big brackets here is because your calculator opens those brackets for you. So once again, and hopefully you can see this, I'll move my screen like this. Okay, so shift cos, and my calculator opens those brackets up, right? But I want my top and my bottom to be in brackets too, so that's why I'm adding this extra set of brackets. 9 squared plus 6 squared minus 7 squared. And I'm closing my top set of brackets. Then I'm doing it divided by, and now I'm doing my bottom set of brackets. 2 times 9 times 6, and I'm closing my bottom set of brackets. And now I'm closing off this big bracket. Okay. can see that's the big one at the end. And now I'm going to equals, and I get angle A equals 50.98 degrees, or 51 degrees. I guess your back of the book would just round to a whole degree thing. So I hope that this is the most difficult one to enter into your calculator, okay? Because it involves a division of a lot of numbers, right? There's a lot of numbers on the top, a lot of numbers on the bottom. Now, if you're using your own calculator at home, it might be easier, right? These graphing calculators are a little difficult to use for trig, but if you're using your home calculator, like I say, I think you might be able to do it a quicker way. So if there are no questions, let's try the next one, I guess. Now, I know this is a law of cosines question just from looking at it, because I've got side, 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 and no angle given at all. I identify who A is, right? It's right across. That's the big one, right? This is A. And once again, it doesn't matter who B and C are. So now I'm going to set up my law of cosines question. So now you could call this A, or if you kind of know how this works, like I can keep calling this theta, right? Cos of theta equals, right? This is my A, but the question calls it theta, so I'm going to call it theta. Cos of theta equals, and again, just call one of them B and one of them C. Now my calculator's going to open this up, right? So it's going to be shift cos, I guess. Okay, so it's going to be little bracket. I'm going to have a top and a bottom, right? I'm going to have little brackets on my top and my bottom. So B squared plus C squared minus A squared, all over 2 times B times C. Okay, so those are my top and bottom brackets. And I'm going to close everything off. And then that should, just setting it up is the hard thing, right? So once again, I'm going to go shift cos. And then I'm going to open up my top brackets. 103 squared plus 87 squared minus 124 squared. Close my top bracket. Divided by, and then I'm going to open my bottom bracket. Two times 103 times 87, close my bottom bracket, and then close my big bracket off. And that gives me 81.01 degrees, or the back of your book would just say 81 degrees. Okay. So, like I say, in your handheld calculator, if you're using your home calculator, not the graphing, I think what you could do is just punch all this in and then hit the shift cos. And that's perfectly fine, and that might be easier for you. So if there's any questions, I will let you work on, I will post these notes. I just have to take pictures and then upload them as PDFs. So I will put the notes on the blog, and I'll let you work on assignment 8. For those people, so that's it for today, unless you have questions for me. For those people interested, I'm just going to show you quickly why it looks like there's 2 versions of law of cosines, but there really isn't. There's only one version of law of cosines, and the law of cosines is A squared equals B squared plus C squared minus 2BC times cos of A. That's the law of cosines, and there is only one. How they got the solving for an angle, what they did is they wanted to solve for this angle, so they just wanted to isolate the angle. And similar to what we did when we were solving equations, what they did is they said they want to isolate this. So what they did is they took this whole piece and moved it to the left-hand side of the equation. So when it moves to the left-hand side of the equation, it becomes like a positive 2bc cos of A. And they're left with b squared plus c squared on the right-hand side, right? And then they move the a squared over to be with the other two sides. So that left a positive 2bc cos of A on the left-hand side. And on the right-hand side, a b squared plus a c squared. When the a moved over, it becomes a minus a squared, okay? So, and then the last thing they did is they just wanted to isolate the cos of angle A. So the right-hand side stayed as the b squared plus c squared minus a squared. And then we wanted to get rid of this, so it just gets divided out of both sides. All right, now you don't have to know that. You don't have to know it at all, but I'm just trying to show you that these two are really the same law. This is isolated to solve for sides, and this is isolated to solve for angles. And that's just to make the student's job easier, right? So you don't have to know that. I just wanted to let you know. So once again, solving for an x, solving for theta. I guess that's it for today for the lesson. And I'm going to assign you assignment 8. So see if you can get that done. And then we'll talk again tomorrow. And I'll figure out ways that I can deliver content to you easily. Or if you don't mind getting them off the blog, maybe I'll get a review assignment ready for you. And then, like I say, once we figure out how long we're going to be away, I will... I'll figure out how we can get unit tests and stuff done. So tonight or today, catch up on any outstanding homework and work on the law of cosines, and come to class tomorrow, I guess, same time, same place, and come with any questions on this assignment or previous assignment, okay? I'll leave the streaming on for a minute or two unless you have any other questions for me, and if I don't hear from anyone in the next minute or so, then I'll just, I'll stop streaming.